believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
He challenged the National Aeronautics and Space Administration to carry American leadership in aviation to new heights. 7 men were first to face these unknown limits, but each mission's fear ended in new hope and new heroes. Man walked on the moon in less than a decade, and the world cheered. The lunar samples opened Earth's history. The Spirit opened our hearts. America's space program was really the world's space program, sharing technologies, inviting teamwork, and exploring further into man's existence. Medicine, science, engineering, weather tracking, the gains America has made in space save lives throughout the world.
Astronaut Bob Overmyer joined NASA in 1969 after being in the U.S. Marine Corps as well as U.S. Air Force Test Pilot School. He worked on the development of the Skylab program and served on the support crews for Apollo 17 and the joint Russian-American space adventure, the Apollo-Soyuz project, where he was the NASA communicator in Moscow. Colonel Overmyer piloted the first fully operational flight of the Space Shuttle, deploying 2 commercial communication satellites. He also was commander of Skylab's 3rd mission and conducted numerous medical and scientific experiments.
Hi, I'm Space Shuttle astronaut Bob Overmyer. America's space program had been grounded since the Skylab missions of the early 70s. Future exploration depended upon our ability to make a cost-effective mode of transportation. NASA scientists and engineers developed the first reusable fixed-wing spacecraft, a model unlike any other. The first mission was to be manned. No spacecraft's maiden voyage had done this. It marked a new confidence in our technology. This film is the story of the first launch of Space Shuttle Columbia. A year earlier, Space Shuttle tiles had shown weak bonding, insufficient to withstand the searing temperatures of atmospheric reentry. All critical tiles went through a densification or bond strengthening to ensure protection from the 2,500-degree temperature. Now it was time to send the Space Shuttle into orbit. Watch and see the exciting liftoff and landing of Columbia. Several thousand spectators witnessed these events firsthand, and millions through television. It was the beginning of a new decade of America's space program and the dawning of a new era. You'll see exciting photographs of the Himalayas and desert regions, as well as video from inside the shuttle. It was the first reusable spacecraft ever flown, out to prove space exploration was vital to our future and achievable through this remarkable flying machine.
Sunday, April 12, 1981, Kennedy Space Center, Florida. The Space Shuttle, 14 stories high, 2,000 tons, poised on the pad for its maiden flight. This is Columbia, the spaceship that will orbit the Earth. Its external tank, it holds over 500,000 gallons of fuel for Columbia's 3 main engines. And the solid rocket boosters, the largest ever used on any launch vehicle and the first to be employed in a U.S. manned flight. At liftoff, the solid rocket boosters, together with the 3 main engines, will unleash more than 6.5 million pounds of thrust needed to launch the world's first reusable spacecraft. Never before has a winged vehicle been launched like a rocket, orbited the Earth, returned through frictional heating in excess of 2,500 degrees, and landed, still aerodynamically sound, to be launched again and again. If it succeeds, the Space Shuttle will truly be a remarkable flying machine. There are many other goals to be reached during the 54.5-hour mission that lies ahead. 144 test objectives are planned for the flight. These objectives could not be achieved without an astronaut crew, The commander, John Young. The pilot, Robert Crippen. Young has already been in space 4 times for a total of 533 hours. He is the most experienced astronaut flying today. Although Crippen has over 4,000 hours of jet aircraft flying time, this will be his first time in space. The astronauts make their way across the access arm toward the shuttle in the pre-dawn hours before launch. An American spaceship has never carried a human crew on its maiden voyage. At the Launch Control Center, 3 miles from the pad, final steps are being completed in the countdown. Final preparations are also being made in the Mission Control Center in Houston, where control of the flight will switch once the shuttle clears the tower.
Okay, now your vent switch to open until
There has not been a manned launch from Kennedy Space Center since the Apollo-Soyuz test project in July of 1975. With this launch, Young and Crippen, launch controllers at the Cape, and flight controllers in Houston will experience the most dynamic, fast-paced series of launch events ever undertaken in the space program, all in less than 9 minutes. The most challenging ascent profile ever to be flown by a space vehicle. Photographers, film and television crews, plus newspaper and magazine writers from around the world, nearly 2,700 of them are here to cover the launch. In addition, approximately 600,000 spectators line the coastal area near the Kennedy Space Center. Arriving by every mode of transportation, they have come from every state in the Union and many foreign countries. The promise of a rebirth in America's manned space program and the dawn of a new era in space transportation awaits.
14, 13, T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start.
Roger, roll. The roll will put the shuttle on its precise heading toward an imaginary target in space.
Roll program complete.
Roger, roll complete.
Status, Vital. Go. Booster, go. DNC, go. Eagle, go. Go at 40, Capcom. Columbia, Houston, you're go at 40.
The shuttle is now 40 seconds into flight.
Roger, Columbia, on a nice ride. You're lofting a little bit, so you'll probably be slightly high at staging.
Negative seats.
Columbia, you're negative seats.
Should anything go wrong, the shuttle is now too high for the astronauts to use their ejection seats.
Columbia, you're going for SRB step.
We see SRB step, flight.
Roger, on a step.
103, converge, flight.
Yeah. Capcom, let's tell them all the calls are going to be a tad early because of the hot first stage. Columbia, you're looking a little hot. All your calls will be a little early.
Okay. And that looks good here. Stand by, press to MECO.
Columbia, stand by, press to MECO.
Mark it.
Mark, press for MECO.
Roger, press to MECO.
The shuttle can now continue toward MECO, main engine cutoff.
Say like you've asked, Eagle. ECOM.
This goes, White.
Capcom, VAPS go.
Stand by, negative return.
Columbia, stand by for negative return.
Mark it.
Mark, negative return. And your VAP is good.
Outstanding. Sure is. We can confirm it. What a view. What a view. And single engine rotor flight.
And Columbia, your single engine rota.
Columbia can land safely at the Naval Air Station in Rota, Spain, even if 2 of the 3 main engines should fail. Right now, the engines are generating over 42 million horsepower.
MECO 25, 6,
MECO.
0, up at 200.
Roger, MECO.
And we got MECO confirmed.
MECO, Roger, Columbia, MECO. Right on the money, nominal.
Main engine cutoff. Columbia is now in space, traveling over 18,000 miles per hour.
Okay, we got set.
Roger, we confirm the SEP, Columbia.
The external tank has just been jettisoned and is now falling away from the shuttle back toward Earth. The tank will break up as planned over the Indian Ocean when it comes into contact with the atmosphere. Shortly, by firing the OMS, Orbital Maneuvering System engines, Columbia will achieve orbit. Then one of the most important tests of the mission will be attempted, opening the payload bay doors. The doors must be opened before the end of the 6th orbit to expose the space radiator cooling system. If the radiators cannot be exposed, heat collected from the onboard electronics cannot be released, and the astronauts will have to return home. The OMS burns are successful. Columbia is now in orbit, circling the Earth at an altitude of approximately 150 miles. The payload bay doors will now be opened.
Okay, the port door's coming open now.
Roger, copy.
Well, you are missing one fantastic sight. Boy, that is really beautiful out there.
We appreciate those updates.
Both doors have been opened. The radiators can be deployed to begin dissipating the heat.
The doors are all opened up and hunky-dory. Glad to deploy right on time.
And the radiators look good.
Okay, we want to show you our own pods here. We do have a few tiles missing off of both of them. Off of the starboard pod, 3 tile and some smaller pieces. And off the port pod, looks like I see one full square and looks like a few little triangular shapes that are missing. And we're trying to put that on TV right now.
Roger, Crip, we can see that good.
From what we can see of both wings, tops and leading edges, though, all those are fully intact.
Within minutes, an assessment is completed on the impact these missing tiles could have on the remainder of the mission. At a news conference later in the day, Flight Director Neil Hutchison answers questions from reporters.
But you asked me if I knew where there were any other tiles that might be loose. The answer is no. And quite frankly, we're not worried about any other tiles being loose.
At this writing, is there anything at all that would lead you to say you might not go for a full duration mission?
Nothing.
Columbia, Houston, you guys did so good, we're going to let you stay up there for a couple of days. Your gopher on orbit.
Spacecraft let's go for on orbit. This thing is just performing just outstanding.
Roger, we agree with that. And Columbia, Houston, just for your information, you dropped those SRBs right on target, and they were floating just the way they ought to be, and the boats were getting ready to fish them and bring them back.
Okay. The ride that they gave us was pretty neat.
The solid rocket boosters, which separated from the Columbia as planned 2 minutes, 11 seconds into the flight, landed on target in the Atlantic Ocean, 151 miles downrange from the launch site. After being towed back to Kennedy Space Center, both boosters will be refurbished and used again in a future shuttle flight. The third and fourth Ohms burns are also successful, raising Columbia's orbit to an altitude of approximately 172 miles. For the first television transmission from inside the spacecraft, the crew will give a status report on the mission.
The flight so far has gone as smooth as it could possibly go. We've done every test that we're supposed to do, and we're up on the timeline, and the vehicle has just been performing beautifully, much better than anyone ever expected to do on a first flight, and no systems are out of shape. And it's delightful up here in zero gravity, might add. Of course, we owe this to a lot of people, and we certainly want to thank everyone who has helped get this thing airborne, and can take great pride in doing so well right now. Okay, we're switching over to the aft camera here. I'd like to echo John's words as I usually do. I guess being the so-called rookie on this flight, I had a thrill from the moment of liftoff all the way up to what we're doing now. It's really been super. The spacecraft has worked as advertised all the way along. I think we've got something that's really going to mean something to the country and the world. This vehicle is performing like a champ, like all of us that have worked so long on it knew that you would.
Okay, sir, we appreciate those comments.
I guess that does it.
That was a good time, and I think you must have practiced. We're just about to lose your ghost off.
Just accident.
Just accident, says Robert Crippen. None of the other events of the day have been accidental. Every test, liftoff, SRB separation and recovery, ET separation and impact, 4 Ohms burns, payload bay door latch opening and closing tests, radiator latch deploy and stowing tests have all been successful.
I guess we owe you guys one super attaboy for today. This is fantastic. You worked through a pretty long, hard day, and you're essentially right on schedule, which is going to be close to being a first for the spaceflight biz, I think, for a first day activity. It's sure been fun working with you today, and we look forward to seeing you in the morning. I hope you get a good night's rest.
Okay, you guys did super work today. See you mañana.
Roger, thank you. See you tomorrow, guys.
Well, many hours went into this thing. A job well done by the shuttle space team. We can't say she's sleek and lean, but I'll tell you right now, she's a mean machine. The Columbia, not the kind you smoke. This here's a bird.
Morning, Columbia. Welcome to day 2.
All right. Appreciate that super wake-up music this morning. Well, we sure enjoyed it. Missing a good breakfast.
Today, the astronauts will test onboard systems and also review procedures for tomorrow's landing. A test of the flight control system is conducted by John Young. The flight control system operates Columbia's aero surfaces, the elevons, body flaps, rudder, and speed brake. These surfaces are useless in the vacuum of space, but will be essential tomorrow when the shuttle lands. This will require precision maneuverability, which the aero surfaces provide. Payload bay door cycling tests help ensure that latching and closing procedures can also be done before entry tomorrow. As with every mission, many pictures of the Earth are taken by the astronauts, over 500 on this first shuttle flight. Active volcanoes, cloud formations, alluvial fans, giant whirlpools over 15 miles in diameter, sand dunes 1,500 feet high, running unbroken for hundreds of miles. The high Himalayas, where mountain peaks reach 24,000 feet. And one of the most remarkable space photographs ever taken of the Earth, an area in Iran exposed to wind erosion, which has resulted in these breathtaking silt and sandstone formations that look more like a painting than a desert. After lunch on the second day, the astronauts receive a phone call from the Vice President of the United States, George Bush.
How's it going up there? Everything rocking along all right?
Spaceship is just performing beautifully.
Well, it's great, and everybody views it, I'm sure, just as the forerunner of great things to come. I think your trip is just going to ignite the excitement and the forward thinking from this country, so I really just wanted to call up and wish you the very best.
We certainly appreciate it, Mr. Vice President.
The crew also don and check out the ejection suits they will wear during entry. Young, Crippen, and Columbia pass every test. They are ready for the final phase of the mission, entry and landing. April 14, 1981. NASA's Dryden Flight Research Center on the edge of Rogers Dry Lake Bed in California. A recovery convoy of 24 vehicles and more than 100 personnel are assembling here to power down Columbia after landing. Enormous crowds are also beginning to arrive. A string of traffic 6 miles long waits to enter the base. Thousands more are already here. Close to 500,000 people will eventually be on hand to see the landing. On board, the astronauts suit up for entry. The ascent and orbital phases of the mission have gone extremely well. Now the final phase must be completed. Before that begins,
Columbia, you have a go for payload bay door closing.
the doors, which have been open a total of 47 hours during the flight, must now be closed. Then, using the RCS thrusters, Columbia will maneuver into deorbit burn attitude, head down and backwards, fire the OMS engines one last time, and descend into the Earth's atmosphere.
Easy does it, John. We're all riding with you.
Columbia is out of contact during the OMS burn. Mission Control will not know if this burn was successful until they are in communication with the spacecraft over Australia. It is now over the Indian Ocean on the other side of the world, but from that distance the burn must be precise so that later Columbia will hit the lake bed target in California.
Columbia, this is Houston through Yargady. We're standing by.
Burn was on time at nominal. It is 110.
Columbia is now committed to entry. With an RCS post-burn maneuver and several firings, it is oriented to a heads-up, nose-first attitude headed toward entry interface. This is where the atmosphere begins, at approximately 400,000 feet. From that moment until the shuttle reaches 165,000 feet, it will be in communication blackout, out of touch with mission control for almost 20 minutes. The landing site is almost 4,400 miles from entry interface. Chase planes are preparing to take off. One will call out altitudes and check Columbia for any damage just prior to landing. When the shuttle touches down here, it will be traveling at 216 miles per hour. Right now, it's going more than 17,000 miles per hour. Before it lands, it must slow down, lose energy, and it must survive the intense heat caused by traveling through the atmosphere at such a high rate of speed. Several S-turns or roll reversals are used to slow down and maneuver Columbia through the atmosphere. This one is done at 256,000 feet, when it is traveling at more than 26 times the speed of sound. This one is done at 208,000 feet. During these two roll reversals, entry heating is most severe, with temperatures reaching 2,500 degrees some places on the vehicle. The aluminum skin will melt at 320 degrees. The silicate tiles must insulate the vehicle from the tremendous heat. Since there is no test facility on Earth to simulate the aerodynamic and structural environment Columbia is in right now, only calculations could be used to predict what would happen during this phase of the flight. The predictions and calculations had to be right.
Hello there, Houston. Columbia's here.
Hello, Columbia. Houston's here. How do you read?
Full and clear, and we're doing Mach 10.3 at 180 AS.
And we couldn't agree more, John. Your state vector's good. We've got good data in required.
Okay.
The entry trajectory, velocity, and position look good. Columbia is heading for home, now only 470 miles away.
More left RCS, but okay.
Right, we're showing a roll. And, John, we're showing you rolling right. Looking good.
Right, normal roll.
We're showing him crossing the coastline flat.
Columbia, we show you crossing the coast now.
Right, yeah. We can come.
The shuttle is first sighted at about 100,000 feet with a long-range camera from Anderson Peak, California.
What a way to come to California.
And flat plateau, I still look perfect, right on the nominal.
Roger that. Out of 112K, 4.8 Mach.
Push me up this in a row.
We see Del Ave, 21 degrees.
A roll reversal is done over Bakersfield, California.
Oh, that's beautiful.
The truth as a tally.
Roger.
And we're seeing 1.3 Gs coming around the hat.
Roger that.
The astronauts are making the final turn to line up with the runway.
Columbia, you're really looking good. Right on the money. Right on the money. And turning on the final, your winds on the surface are calm.
Right on the wind.
You're right on the glide slope, Columbia.
Yeah, clear, John.
Looks real good up in here. Everything looks real good.
Chase reports no tile or other damages evident underneath the shuttle. Columbia's altitude is now just over 5,000 feet.
Pretty clear?
Without power, Columbia must land. It cannot make another attempt.
Good comment. Go down. Feet. 40, 30, 20, 10, 5, 4, 3, 2, 1, down. That was good. 5, 4, 3, touchdown. Look at all, skipper.
Welcome home, Columbia. Beautiful, beautiful.
us to take it up in the hangar, Joe?
We're going to dust it off first.
This is the world's greatest all-electric flying machine, I'll tell you that. That was super.
Okay, convoy's on its way.
Convoy on. We'll stop on the Columbia. We'll stop.
The maiden voyage of Columbia has been a success. The astronauts and the vehicle have met or exceeded all 144 flight test objectives. The integrity of all the systems, propulsion, avionics, structural, flight control, power, and thermal, have been affirmed. John Young's comments after returning home.
I can't tell you what a tribute that is to the American working man and the American working woman, too. You can't imagine the variety of people who worked on this vehicle, from all walks of life, all capabilities and limitations. It's all due to their individual efforts. They proved that they can do the job. They proved it for the world to see. And I'm mighty proud to be associated with folks like that.
What a tribute indeed. The Columbia represents an achievement in aerospace technology and development never before realized in the history of manned spaceflight. It is our basic building block for the future.
It's what we've been trying to do for the last 10 years. We've got a vehicle with a payload performance that will allow us to do that, much cheaper than we've been able to do it before. It will immeasurably improve the defensive capability of the country. It will help develop space science and technology. When we get operational, the Space Shuttle will be able to do in 5 to 10 years what it would have taken us 20 to 30 years to do otherwise. We couldn't do it if we didn't have the Space Shuttle and that payload capability. And the sooner we do those things, the better off the country's going to be.
A revolutionary new era in space transportation has just begun. Routine access to space. Welcome to the future.
Astronaut Rick Houck joined NASA in 1978 in preparation for the Space Shuttle program. Houck served in the support crew for the first 2 missions and then piloted Challenger in 1983. He flew into space again aboard Discovery, one of the 3 Space Shuttle orbiters. Following the Challenger disaster of 1985, Houck flew the next shuttle mission into space. This was the 26th Space Shuttle mission and America's return to space.
Hi, I'm Rick Houck. Are you afraid of heights? Many of our astronauts have stood on the edge of the space shuttle hundreds of miles from Earth. If you get dizzy looking down from a mountain or a building, think about looking out into the endless black of space. Below you glows a beautiful blue Earth, and all you hear is yourself breathing inside the spacesuit. As one astronaut said, it's like being on the world's highest diving board. The film you're about to see has some spectacular footage of spacewalks around the shuttle. It looks like the astronauts are floating calmly, but they're actually moving at over 17,000 miles per hour. You'll see spectacular views of our Earth, as well as shots of the astronauts wrestling with the giant Intelsat satellite. The Endeavour Intelsat repair mission highlighted the versatility of the space shuttle and astronauts in space. Watch this exciting rescue mission. It teaches everyone that teamwork is the best way to win. And when America's top astronauts, engineers, and scientists work together, adversity leads to discovery and success.
From the beginning, STS-49 would stand out as an extraordinary mission. As Endeavour rolled onto the tarmac in Palmdale, California on April 25, 1991, it set the stage for America's 47th Space Shuttle mission. Endeavour was a milestone, bringing the shuttle fleet back to full strength after the loss of the Space Shuttle Challenger, signifying a new level of confidence and ambition for the American space program. But the maiden voyage of Endeavour would prove to be not only a test of the space transportation system, but a test of the entire space flight program. After more than a year of intensive training, the crew of Endeavour was ready to face the complex inaugural voyage ahead. Navy Captain Dan Brandenstein commanded the crew of 7, while Air Force Lieutenant Colonel Kevin Chilton served as pilot. The piloting skills of both men would be crucial to the success of the mission. The remaining members of the crew, mission specialists Richard Heeb, Dr. Catherine Thornton, Coast Guard Commander Bruce Melnick, Air Force Lieutenant Colonel Tom Akers, and Navy Commander Pierre Thuot, shared in the responsibility of achieving the mission objectives. The primary objective, the retrieval, repair, and reboost of the International Telecommunications Satellite, or Intelsat 6 F3. A wiring error on the unmanned commercial booster rocket marooned the satellite in a useless low orbit after its launch in 1990. Intelsat commissioned NASA to rescue the stranded satellite. Though this was not NASA's first satellite rescue, it would be one of the most challenging for the Space Shuttle program. Endeavour and her crew would engage in the first attachment of a solid rocket motor in orbit, and the first attempt to perform 3 consecutive spacewalks. Another objective of the flight would be the assembly of station by EVA methods experiment, or ASEM. The mission specialist teams of Akers, Thornton, Thuot, and Heeb would perform EVAs, or spacewalks, to evaluate equipment and techniques for the construction of Space Station Freedom. In the payload bay, the astronauts would build a truss structure and evaluate EVA operations to be used for space station assembly. To achieve these objectives, the crew of Endeavour underwent months of rigorous training at NASA's Johnson Space Center in Houston, Texas. At the Precision Air-Bearing Facility, a mock-up of Intelsat 6 was used to assess how the satellite would respond in space and to demonstrate the capabilities of the unique capture bar.
Okay, one more time at half. Why don't you guys put a little wobble in it, if you can.
Thuot would use the capture bar to catch the satellite and stop its rotation. The bar included a grapple fixture for the robot arm to grab the satellite and place it on top of the solid rocket motor.
Okay, that's better.
Thuot and Heeb continued their training in the weightless environment training facility. This training focused on the task of attaching the satellite to the solid rocket motor and preparing it for its launch from the shuttle cargo bay. It would pay off handsomely in space. The complex dynamics and interactions of satellite, shuttle, robot arm, and astronaut were difficult, if not impossible, to recreate on the ground, and proved to be the most serious challenge facing the satellite rescue mission. May 7th, 1992, a relaxed and confident Endeavour crew heads for the launch pad. Weather problems persisted throughout the day, but the rainy skies couldn't dampen the spirits of the 7-member crew.
Lock your visors and initiate O2 flow. Good luck on the maiden voyage of the newest shuttle Endeavour.
T-minus 10. We have a go for engine start. 6, 5, 4, 3, 2, 1. Booster ignition and liftoff of the maiden voyage of Endeavour on a satellite rescue mission.
Roger, roll, Endeavour.
SRB separation confirmed.
Following a flawless liftoff and ascent, Endeavour settled into orbit. Over the next 2 days, Endeavour and the stranded satellites circled the Earth while performing a series of crucial maneuvers as a prelude to the rendezvous. The success of this unique mission would require an unprecedented level of coordination between the Intelsat control facility in Washington, D.C. and mission control in Houston. An intricate dance ensued as the flight crew gradually raised Endeavour's altitude and Intelsat controllers lowered their spacecraft.
This is a 45-second burn of the twin orbital maneuvering system engines that produce about 6,000 pounds of thrust, raising Endeavour's low-ends orbit from 146 to 187 nautical miles, getting it closer to a more circular orbit as it continues its chase to catch up with the Intelsat spacecraft.
As the countdown to the first spacewalk proceeded, crew members began the checkout of the robot arm and spacesuits.
And Houston, as you gathered, we've completed equipment prep, and as you can see, it's just as crowded as we expected it to be.
And we copy, Pierre. Thanks.
On Sunday, the 4th day into Endeavour's mission, Thuot and Heeb stepped into the payload bay to begin the first rescue attempt. While Thuot grappled the satellite, Heeb, from his unique vantage point in the payload bay, served as an extra pair of eyes for the cockpit. Melnick operated the robot arm from inside the orbiter.
Okay, you ready to go for it? Okay, go for it. Hey, Pierre, here we go.
Unfortunately, the cards were stacked against the crew this day.
In a little bit, Bruce. Coming in. Oh, I missed it. Hang on. Okay, have to catch it next time. Okay, we got a rate on it now.
The capture attempts caused the 4.5-ton satellite to wobble so much it became impossible for Thuot to attach the capture bar. Endeavour was forced to back away to avoid a collision with the satellite.
Verify the shower cap pedals that we flipped up are secured.
Rendezvous and Fidos are working on a best maneuver for you to back out here so we can stabilize for about 6-8 hours. We'll try it come in again tomorrow.
Okay, and that sounds good. We got slide opening rate, and we're comfortable right here.
Okay, sounds good. We'll have some words for you shortly.
Rotation rate on the arm. This was a full pitch deflection.
After analyzing the downlink footage from Endeavour's cameras, the crew held a conference with Mission Control to discuss conditions contributing to the unsuccessful attempt. Prime factors included the satellite's unexpected sensitivity to touch, the unanticipated movement affecting Thuot's positioning on the robot arm, and reduced visibility on the dark side of the Earth. The next step was clear. A second attempt would be made on Monday.
Probably the most important question first, and that's where was the...
Engineers on Earth struggled throughout the day and into the night to come up with a better way of capturing the satellite. Monday, May 11th. Thuot and Heeb stepped from the airlock into the payload bay. While Mission Control had brainstormed for the second EVA, the crew had come up with a few suggestions of their own. They would attempt the capture in maximum sunlight to give Thuot the best view. Time would be allowed for a bump test, bumping the capture bar against the left side of the cargo bay to familiarize Thuot with the dynamics. This would also determine how the bar would respond when striking the satellite in a weightless environment. Perhaps most importantly, Brandenstein would have to keep Endeavour in position beneath Intelsat for as long as it took Thuot to get into optimum position.
Awaiting good sun angles now to begin maneuvering Pierre Thuot on the end of the robot arm into the tail end of the satellite.
Yet, despite the planning and coordination between ground and space, this second attempt also failed.
Fire. I do believe. On. Good. Nope, not. Oh, no. Back away. Uh-oh. Surely you had it.
During the 5.5-hour spacewalk, Thuot made 5 attempts to attach the capture bar to the satellite.
And you were right in there.
Yeah.
On the left beam end, I could see clearly.
That was right. That was when I was looking at. I can't see the left one because it's hidden by the bar, but
Yeah, I saw the left one.
it almost looked like you stopped the rotation. I think you did some. You stopped the rotation. It wasn't enough to fire the latches.
Yes, that's true.
Problems arose when the trigger release on the grapple bar failed to snap into place due to the delicate equilibrium of the orbiting satellite.
So let's go in. Put the right thumb and down. Go in. Hold it right there. Dang it. Why it's not grabbing? I didn't get it. That might be all of it today.
The situation was becoming increasingly frustrating. After the second attempt, Thuot noted a wide margin of difference between performing the capture in NASA's microgravity simulators and actually trying it in space. Because of Brandenstein's piloting skills and frugal use of fuel on the second attempt, enough fuel remained for one more rendezvous.
And Dan, we've been looking at the prop. Just want to tell you that your formation flying there has been outstanding. We've had practically no forward prop usage at all. Fine job you're doing.
A third attempt was immediately approved, but a replanning of strategy was clearly necessary.
All right, Endeavour Houston, with kind of the big pictures, we're planning on an 8-hour sleep period, no EVA for tomorrow. We're going to rendezvous with Intelsat on day 7.
These guys grab it, stabilize it, de-spin.
Human intelligence was Endeavour's strongest ally, and ingenuity and adaptability were crucial to success. The hours that followed were a maze of brainstorming sessions and hands-on tests. For veterans of the space program, the level of activity was reminiscent of the early days of Gemini and Apollo. The Tiger team, a group of troubleshooting specialists, discussed the options available.
But we got 1 day left, 1 attempt left. Where do you want to put all your eggs?
Among the ideas suggested, a revised 2-man spacewalk to capture and repair the satellite. Engineers also discussed using the orbiter's robot arm to maneuver a crew member to the top of the satellite and capture it from there. Meanwhile, the crew came up with a simple yet revolutionary plan, a record-setting 3-man spacewalk, a first in the history of the space program. The crew downlinked a sketch photographed on the electronic still camera developed by Johnson Space Center to demonstrate their plan to mission control. 3 astronauts, Thuot, Heeb, and Akers, would attempt to capture the satellite by hand.
You've got the capture bar. Regardless of the orientation, our big thing right now is this may not be clean. You know, this is not, I mean, it doesn't even have to be pretty. We just have to get this thing, but it has to be safe.
Safety was a primary concern. Piloting had to be exact to ensure there would be no risk of a collision between the satellite and the orbiter. Every possible danger was assessed.
So the 3 crew members will be putting on their suits and climbing into the airlock, along with all of their tools and equipment that will be necessary for tomorrow's spacewalk attempt to capture the Intelsat spacecraft.
In addition, there was some concern as to whether the 3 astronauts could fit into the airlock. So, before the plan was approved, it was tested in the orbiter and on the ground. Dozens of engineers, astronauts, and other specialists debated and tested the plan by using mock-ups of Intelsat in the underwater tank with astronauts Story Musgrave, Rich Clifford, and Jim Voss. Similar mock-up demonstrations were conducted on the air-bearing table.
Okay, we just came out of the mission management meeting and presented the plan, and I think we've got something that is going to pull together here.
The go-ahead was given Tuesday night. The third and final attempt would be made the following day.
Covered as many of the bases as we could today.
Good evening, friends. A high drama is being played out in space right now.
A risky rescue attempt, an unprecedented mission.
While the astronauts worked 225 miles above the Earth, Americans kept an ear to their radios and an eye on their televisions for the latest news.
4 minutes ago, the crew of Endeavour...
Good evening. The drama in
and many were eagerly offering their own suggestions on how to capture the stranded satellite. Velcro, fishing hooks, and lassos were some of the methods suggested.
The riskiest.
Wednesday, May 13th, Brandon Stein and Chilton began maneuvering the orbiter closer to the satellite. 12 miles behind the satellite, as they approached the most critical burn of the rendezvous, they discovered a previously unencountered glitch in Endeavour's computers. At the same time, a thunderstorm over a ground communications site caused the crew to lose contact with mission control. The computer problem on board Endeavour meant Brandon Stein and Chilton would not be able to compute the final critical rendezvous burns. Ground control studied the problem with only minutes to decide to continue the rendezvous or delay for one orbit. Another option was to skip today's attempt and study the problem for another day.
I'm going to do. If we can get some confidence back in the solutions, what I'm looking for is something that'll bail me out for loss of comp. Otherwise, I'm going to burn ground.
Or should they try it without the onboard computer and attempt a ground-controlled approach to the satellite? This type of approach meant that data normally collected by the shuttle's computer would need to be calculated on the ground and relayed up to the crew. With only 45 seconds until the burn, Endeavour regained communications with Houston. The decision was to delay. Heeb, Thuot, and Akers were already in the airlock and waited another hour and a half in their cramped quarters. Precious fuel had been used to execute the delay maneuver. Now, more than ever, Brandon Stein must fly a perfect final approach. He accomplishes this with fuel to spare. An anxious nation held its breath as Thuot, Heeb, and Akers left the airlock.
Out in the payload bay, 3 spacewalking astronauts are preparing to install the bottom plane of the assembly of station by EVA methods hardware.
After building a bridge structure across the payload bay using struts from the space station test and portable foot restraints, the trio positioned themselves for the capture. Heeb on the edge of the payload bay, and Akers on the strut spanning the payload bay. Thuot, on the robot arm, adjusted his movements in coordination with the satellite. Meanwhile, Brandon Stein positioned the crew at eye level with the underside of the satellite. In this attempt, every detail had to be exact.
With the coding, it may just come right back to Tom. Over. It may. I guess all we can do is kind of sit here and wait for the right opportunity. And I haven't got anything else on my dance card. Over. Yeah, real easy, guys. Real easy.
us any closer, Dan.
Okay, I'm stopping it.
I'm afraid it's going to rise out of my reach, but we'll see. Over.
And, as the saying goes, the third time was a charm.
I can get it.
Can you get yours, Tom?
I can get mine.
Okay. Wait. Let's do it.
Got it. All got a good grip?
Yes, sir.
Houston, I think we got a satellite.
Yeah, we're watching down here. We got a lot of smiles down here, Dan.
It ain't over yet.
Indeed, it wasn't over yet. But with the most difficult part of the mission behind them, things could now proceed as planned. After rotating the massive satellite, Thuot and Heeb attached the capture bar. Once in place, Melnick maneuvered Thuot under the satellite to tighten the bar. To do this, Melnick had to move the robot arm, with Thuot still attached, extremely close to the orbiter and truss structure. This unexpected task was not part of the pre-mission training. Once Melnick used the robot arm to lower the satellite into the cargo bay, a new booster rocket was secured. When it was all over, another record had been set for the longest spacewalk in the history of the space program, 8 hours and 29 minutes. With the crew safely inside the airlock again, the satellite was ready for deployment.
There's a delay, don't worry. Yeah. There's a delay.
There's a delay?
Yeah.
How much?
However, the onboard wiring configurations on the new orbiter were different than anticipated by the ground staff, so some minor readjustments were required by ground support.
Primary deploy A arm on, talkback gray. Stand by for fire. 3, 2, 1, fire. Astonished.
Tell you, that old boy didn't want to go, did he?
After 2 attempts to deploy, ground controllers sorted out the wiring change, communicated the correct switch positions to the orbiter, and Intelsat 6 was on its way to its intended orbit of 22,300 miles. But Endeavour's work was yet to be completed. Mission managers decided to extend the mission an extra day, allowing for a 4th spacewalk on Thursday to practice the space station assembly techniques. The crew had originally planned 2 days for these spacewalks. But since the space station test structure had been partially built for the satellite rescue attempt, they were able to incorporate most of the activities of 2 days into one.
And just so you know, the game plan for the day, it's another day, another EVA.
That's the type of game plan we like.
On Thursday, the attention of the crew and the nation was again on the payload bay. With the 4th and final EVA of Tom Akers and Kathy Thornton, the crew of Endeavour set the record for the most spacewalks in NASA's history. The pair spent 7 hours and 45 minutes demonstrating techniques to be used during space station construction and maintenance. However, this spacewalk was not without its complications. When the crew members used foot restraints to control their body positioning, the time required to accomplish a task in space was very close to the time required in the water tank. But free-floating exercises proved much more difficult and time-consuming. Mission planners will use the lessons learned during the 4 spacewalks to increase the efficiency, training, and techniques to be used in the assembly of Space Station Freedom.
Endeavour Houston, good morning. The SDS-49 trainers send Dan and his spacefaring crew their best for making the maiden voyage of Endeavour a spectacular success. They wish you well as you start preparing to come home to port.
Well, good morning, Houston, and thank our training team of those fine words. We couldn't have done it without them getting us squared away before we left.
Endeavour and its crew sailed into the 9th day of the mission, preparing the orbiter systems for the trip home the next day. It was a day for reflection as the crew held a news conference from the orbiter.
We were speculating how many people were involved. We knew it was a lot, but we didn't have a clue how many it was. And they did a fantastic job. There was, we had some ideas, they had some ideas, we shared them. They had a lot of data we didn't, and went off and worked it and came up and fine-tuned some of our ideas with theirs, and you saw the end result. It just proves that NASA has a great team and can really do the job when the chips are down.
With the mission objectives behind them, the crew prepared the orbiter for re-entry.
Endeavour Houston, you have a go for the deorbit burn.
All right, Houston, go for deorbit burn.
But before putting this mission in the books, Endeavour had one more test. After touchdown at Edwards Air Force Base in California, a drag chute was deployed from the back of the orbiter. Engineers designed the chute to improve braking and steering control during landings. Long after Endeavour has been rolled off the runway in preparation for another mission, planners and engineers will use the information and knowledge gained on this flight to improve future flights. In hindsight, most agree the reasons for mission success were clear. Despite the problems often associated with a maiden voyage, Endeavour performed flawlessly.
We felt pretty good about the mission. It had been real interesting and challenging, and we're real happy with the way Endeavour performed. It performed like a real champ, which is phenomenal for the first flight of a new vehicle.
Perhaps the simplest explanation for this mission's success is the team effort, the ability to adapt and learn in the face of adversity, demonstrated by both the crew and ground staff. Proof that people are a vital link in the American space program, now and into the 21st century.
Astronaut Bob Overmeyer joined NASA in 1969 after being in the U.S. Marine Corps as well as U.S. Air Force Test Pilot School. He worked on the development of the Skylab program and served on the support crews for Apollo 17 and the joint Russian-American space adventure, the Apollo-Soyuz project, where he was the NASA communicator in Moscow. Colonel Overmeyer piloted the first fully operational flight of the Space Shuttle, deploying 2 commercial communication satellites. He also was commander of Skylab's 3rd mission and conducted numerous medical and scientific experiments.
Hi, I'm Space Shuttle astronaut Bob Overmeyer. For more than 30 years, America's space program had been reaching new heights, from Mercury's first man in space to Apollo's first man on the moon. The next critical phase was determining an economical means of repeated space flights, capable of carrying commercial and scientific payloads. And so, the Space Shuttle was born. The film you're about to see is a story of the first 4 flights of the NASA Space Shuttle, the Orbital Flight Test Program. It was a series of flights designed to test the world's first reusable spacecraft. Watch President Reagan address the crowd at Edwards Air Force Base on July 4th, 1982, celebrating the completion of Space Shuttle flight testing, an appropriate date to celebrate our newfound freedom in space. As the Space Shuttle Columbia lands with the grace of a glider, you'll witness one of America's proudest moments, but you'll also see it wasn't all glory. The painstaking testing of engines, thermal protection tiles, and other sensitive pieces of equipment took years. Finally, it all came together in April of 1981 with the first test flight of Columbia. Every flight of the flight test series is an anxious journey for everyone, from engineers to the astronauts. All of the training and testing serve to prepare not only the spacecraft and the astronauts, but just as important, it prepares the ground controllers for the missions that are opening new frontiers.
In the early days of our republic, Americans watched Yankee clippers glide across the many oceans of the world, manned by proud and energetic individuals, showing our flag, breaking records for time and distance, opening up new vistas of commerce and communications. Well, today, I think you have helped recreate the anticipation and excitement felt in those home ports as those gallant ships were spotted on the horizon heading in after a long voyage. The fourth landing of the Columbia is the historical equivalent to the driving of the Golden Spike, which completed the first transcontinental railroad. It marks our entrance into a new era. The test flights are over. The groundwork has been laid. And now we will move forward to capitalize on the tremendous potential offered by the ultimate frontier of space.
When thousands of civilians began pouring onto a military base, located on a desert in the middle of summer, early on a Sunday morning, one could sense the day's events were going to be special. Spectators came to Edwards Air Force Base from all over the nation and all walks of life to celebrate the nation's 206th anniversary of independence and witness historical events more spectacular than the typical 4th of July fireworks display could ever hope to equal. The fourth landing of Space Shuttle Columbia, world's first reusable spacecraft. Columbia's first landing on a concrete runway, officially ending the orbital flight test program. Takeoff of the second orbiter in the shuttle fleet, Challenger, on its ferry flight to Kennedy Space Center, Florida, to be launched into space in the early part of 1983. And with Shuttle Pathfinder Enterprise as backdrop, the announcement of America's new space policy by President Ronald Reagan.
Beginning with the next flight, the Columbia and her sister ships will be fully operational, ready to provide economical and routine access to space for scientific exploration, commercial ventures, and for tasks related to the national security. Simultaneously, we must look aggressively to the future by demonstrating the potential of the shuttle and establishing a more permanent presence in space. Our goals for space are ambitious yet achievable. We've only peered over the edge of our accomplishment.
Surely, our accomplishments began with Columbia's first launch in April 1981.
Roll program. Go. Roger, roll. Roll program complete. Roger, roll complete.
Looking back at that spectacular event and the performance of Space Shuttle during its first 4 flights, there seems little doubt now that it is a reliable, reusable space transportation system. When Columbia first arrived at Kennedy Space Center in March of 1979, there was some skepticism. 2 factors were leading to major delays in the launch schedule. The quest to advance the state-of-the-art in space technology, particularly in engine design and thermal protection, plus budgetary limitations imposed on development and testing of shuttle systems. With 2/3 of shuttle's tiles already on the vehicle, it was discovered that the bond was not strong enough to keep the tiles from falling off during high-stress phases of flight. The fix, called densification, required that most of the tiles be taken off, coated with a material to increase the bonding strength, then reapplied to the vehicle. The process took over 1 year to complete, but it worked. During the orbital flight test program, only undensified tiles showed weakness along their attach points on non-critical areas of the vehicle. Shuttle's main engines achieved the state-of-the-art in rocket engine technology. But as with any research and development program, confidence in the design came only after years of testing, learning, and some mistakes. Problems encountered during development of the engines were related to the unique requirements that had to be met. Reusability, up to 55 flights with minimum maintenance. Ability to throttle down to 65%. Lightweight, yet the capability to withstand extremely high chamber pressure. Pressure needed to generate the thrust for liftoff. Many failures that occurred were due to the tremendous pressures and vibration levels created trying to produce the needed thrust. But one by one, the problems were solved. The design was proven long before the first launch.
Go for auto sequence start. 9, 8, breakers closed. 5, 4, we've gone for main engine start. We have.
Columbia was launched. Again. And again. And again. Four times within 15 months, traveling over 8 million miles during the first 4 flights. "314 revolutions around the Earth. 19 days on orbit." But beyond the statistics, a far more important goal was achieved with completion of the orbital flight test program. The foundation for our future was built, step by step, mission by mission. The goal of STS-1 was, quite simply, to get up and get down safely.
Columbia, Houston, you guys did so good, we're going to let you stay up there for a couple of days. Your goal for on orbit.
When astronauts John Young and Robert Crippen heard that announcement, they knew the mission was at least half a success. When returning from space, friction created by entering Earth's atmosphere blocks communication between mission control and the astronauts for 15 to 20 minutes. But it is also precisely during that time that temperatures on the vehicle surface reach their peak and shuttle structure undergoes its most stringent test. On Columbia's first flight, no one could predict exactly how shuttle would perform during that phase.
Hello there, Houston, Columbia's here.
Hello, Columbia, Houston's here. How do you read?
Flying clear, and we're doing Mach 10.
With voice contact reestablished, spacecraft and crew had safely passed through the most critical phase of entry. Landing was the final test. Flown as a glider, Columbia landed without power on the first and only attempt.
They're coming. Go down. 50 feet. 40, 30, 20, 10, 5, 3, 2, 1, touchdown. Third gear, 10 feet. 5, 4, 3, touchdown. Houston, Columbia's on the roll.
Welcome home, Columbia. Beautiful, beautiful.
Columbia's second flight was the first opportunity to evaluate the Canadian-built remote manipulator system. Manual functions were tested by astronauts Joe Engel and Richard Truly. Automatic functions were computer-controlled. The arm performed successfully in all operating modes. Preliminary thermal tests of the vehicle were also begun on Flight 2. One thermal attitude resulted in the payload bay being pointed toward Earth for extended periods of time. During those periods, a package of 5 Earth-viewing instruments, designated OSTA-1, was activated. The package, composed of low-cost commercial-grade sensors previously flown only on aircraft, and instruments flown on individual satellites or past manned missions, collected the first Earth resource data using shuttle. The ability to mount all 3 types on Columbia greatly reduced the expense of acquiring the data.
Okay. 100, 50, 30, 20, 10, 5, 3, touchdown. Nose gear 15. 10, 5, 3, touchdown. Welcome home. Thank you, Chase.
Flight 2 proved shuttle was truly a reusable space transportation system. Third flight of Columbia was primarily a thermal test of the vehicle, exposing it to the most extreme temperature differentials it could encounter on orbit during upcoming operational flights. No facility on Earth could simulate the same heating conditions Columbia would experience in the vacuum of space, where temperatures could vary greatly from one end of the orbiter to the other, depending on its orientation to the sun. The thermal tests determined precisely what effect different attitudes had on shuttle structure. The vehicle suffered no adverse effects. Evaluation of the remote manipulator system continued on Flight 3. Astronauts Jack Lousma and Gordon Fullerton tested the system's payload handling capability. First order of business was unberthing. Although clearance around the payload was only 2 inches, Fullerton unberthed in just 5 minutes, much quicker than had been predicted pre-flight. Using the plasma diagnostics package, 7 computer-controlled automatic movements of the arm were evaluated to prove scientific instruments could be maneuvered in and around the payload bay.
Some general comments on the arm operation. The operation is smooth. There's definitely a little bit of flex and dynamics, but in the augmented modes, that's very minimized. Really no surprises. If there are any surprises, they're all pleasant. I'm really impressed with that piece of machinery.
Hey, that's great news, and we were impressed too.
The plasma diagnostic package was one of 10 instruments making up a scientific package on Flight 3 called OSS-1. Shuttle's movement through the ionosphere, electrical buildup on surfaces as it circled Earth, and electromagnetic interference between the ionosphere and electronic equipment on board were evaluated by the OSS-1 instruments to ensure that these phenomena would not adversely affect scientific instruments or sensitive astronomy observations on future shuttle flights. On Flight 4, the Induced Environment Contamination Monitor was used to check for contamination in and around the payload bay, created by thruster firings, outgassings, and water dumps. 11 separate components of Shuttle's induced environment were measured. The desk-sized monitor was the heaviest payload lifted by the remote manipulator system during the orbital flight test program. Thermal tests on the vehicle were completed during Flight 4. The first Department of Defense payload was on board. The spacesuit to be used for extravehicular activity on Flight 5 was tried on during Flight 4 to practice the procedure. And astronauts T.K. Mattingly and Henry Hartsfield conducted a thorough evaluation of on-orbit procedures for the upcoming operational era of spaceflight, when Columbia will launch into Earth orbit on a routine basis. An ongoing task on all 4 missions of the flight test program was to evaluate living conditions on board shuttle. Items included food preparation, use of a food warmer, a freezer on board Flight 4, and eating in weightlessness. Personal hygiene tasks were evaluated. As were sleeping conditions, use of sleep restraints, and a sleeping bag. Astronauts also evaluated the effects of exercise in zero-G. This unique device, designed by a fellow astronaut, allowed the user to monitor his own heartbeat while jogging. Alternate methods of anchoring oneself in weightlessness were also appraised. Very busy schedules are forecast for upcoming shuttle flights, when crews will be comprised of at least 4 people, including women. Procedures on the ground are being streamlined for the operational era. Processing time was cut in half during the orbital flight test program. Presently, it takes approximately 13 weeks to prepare the space transportation system for launch. It is projected that by the mid-'80s, there will be 2 shuttle launches per month. The number of people in mission control is gradually being reduced. Some positions have been eliminated. Others have been consolidated, which represents a clear indication of confidence in Columbia's systems. While this monitoring is being streamlined, payload monitoring is increasing. A new area called the Payload Operations Control Center was activated during the orbital flight test program to give mission controllers, payload managers, and commercial users the opportunity to develop monitoring and data acquisition procedures for upcoming flights. Experiments in life sciences were carried on board Columbia during the orbital flight test program. A preliminary study of lignin growth in zero-G was conducted. Lignin is an indigestible skeletal substance which promotes strength and upward growth in woody plants. It is hoped that in the absence of gravity, woody plants might not need to produce as much lignin, and instead will produce more digestible nutrients, such as carbohydrates and proteins. The effect of weightlessness on some flying insects, bees, moths, and flies, was studied. The project, conceived by a high school student, was one of 3 experiments flown on Columbia as part of an annual science competition co-sponsored by NASA and the National Science Teachers Association. Equipment to process materials in zero gravity on future flights underwent initial testing during the orbital flight test program. The monodisperse latex reactor made polystyrene latex microspheres to determine if large identical-sized latex microspheres could be manufactured practically and economically in space. Presently, large microspheres cannot be produced in uniform sizes on the ground. Yet medical and industrial applications have already been found in cancer research and treatment, glaucoma research, and for calibration standards in medical and scientific equipment. The continuous flow electrophoresis system, built by McDonnell Douglas Corporation, is a prototype of a production unit to purify material for the treatment of disease. The process separates substances according to their electrical charge. Hopefully, yields from the production unit will be high enough to make the product available to a mass market in the future. Results from the prototype's first flight showed that a very thin, yet highly concentrated stream of protein substance on the left was separated from red dye on the right. The thin protein stream, only a portion of which is shown here, is actually over 43 inches long and is 300 to 400 times more concentrated than yields obtained from the same process on Earth. The continuous flow electrophoresis system represents the first commercial use of shuttle by private enterprise under a joint endeavor agreement between NASA, McDonnell Douglas Corporation, and Ortho Pharmaceuticals Corporation, a subsidiary of Johnson & Johnson. A unique opportunity to put small, self-contained payloads aboard shuttle on a space-available basis at a very low cost exists in the Getaway Special program. After proving its flight readiness on Flight 3, the Getaway Special was fitted with 10 experiments built by science students from Utah State University and flown on Flight 4. Deposits for Getaway Specials on future flights, private enterprises' interest in flying payloads on board shuttle, missions planned into the next decade, all reflect the confidence this nation has in the space transportation system. All objectives of the flight test program were achieved. Two of the most significant events were not planned. Just prior to the third launch, tons of landing and recovery equipment had to be transported from California to New Mexico, a 1,000-mile journey, because heavy rains in California prevented a landing there. An entire encampment had to be built at the New Mexico landing site, Northrop Strip, and the task had to be completed within 4 days. Just prior to landing on the same mission, only 1.5 hours before touchdown, an unexpected sandstorm blew into the area.
As you could probably surmise, the winds have been coming up all day. It was still acceptable until his last pass, but during John's last pass, the visibilities were unacceptable and the turbulence was severe. So it's not a good day, and we're going to wave off for 24 hours. Over.
Plans were implemented immediately to stay on orbit an extra 24 hours.
We had a good drill.
The flexibility to remain on orbit until weather conditions improved and land at an alternate strip could not have been demonstrated by previous spacecraft. Only the shuttle has that capability. It meets a need, providing access to low Earth orbit on a routine basis. By launching on time, serving as a platform for Earth observation and space observation, deploying payloads, operating in extreme temperature differentials while on orbit, providing ample living accommodations for astronaut crews, landing on lake beds, or concrete runways. As President Reagan said, the end of the orbital flight test program marks our entrance into a new era. The test flights are over. The groundwork has been laid. Now we will move forward to capitalize on the tremendous potential offered by the ultimate frontier of space.
Astronaut Bob Overmyer joined NASA in 1969 after being in the U.S. Marine Corps as well as U.S. Air Force Test Pilot School. He worked on the development of the Skylab program and served on the support crews for Apollo 17 and the joint Russian-American space adventure, the Apollo-Soyuz project, where he was the NASA communicator in Moscow. Colonel Overmyer piloted the first fully operational flight of the Space Shuttle, deploying 2 commercial communication satellites. He also was commander of Skylab's 3rd mission and conducted numerous medical and scientific experiments.
Hi, I'm Space Shuttle astronaut Bob Overmyer. America had tested the Space Shuttle through 4 missions and determined it would revolutionize space travel. The next 4 missions would focus on satellite deployment and scientific experiments, such as material processing and biomedical research. With the increasing success of each mission, America grew more confident. Many first and exciting discoveries refueled our space program and kept it moving into the future. This film documents Space Shuttle missions 5, 6, 7, and 8. You'll see dynamic video and photography of satellite deployment, the Space Shuttle orbiting Earth, as well as the liftoffs and landings. I was the pilot of Space Shuttle Mission 5. Share with me its historic launching of large communication satellites for the first time from the Space Shuttle. You'll see the exuberance of our crew as the mission objectives were fully achieved. On these 4 flights, America put the first woman and Afro-American into space, conducted the first spacewalk from the Space Shuttle, and established an efficient and more productive communication network that would give ground control constant access to the Space Shuttle. A newer orbiter, the Challenger, would be used after Mission 5. It allowed increased scientific payload weight, furthering the shuttle's cost effectiveness. Watch as astronauts use a new design in spacesuit technology during the first spacewalk in 9 years. Space exploration continues to reach new heights, and with America's growing support, bringing the heavens closer to Earth is something we deliver.
Okay, the port restraint is out. Here comes the spin. Here it goes.
Yeah, we see it down here, Bill. It's beautiful.
Okay, Mike, we're at 52, coming back down to 51 RPM.
Roger, we copy. You guys look good. And Columbia, Houston, everyone down here is go for deploy with 2 minutes left over Hawaii.
And so is everyone up here.
Roger, we copy.
Mike, we hope the TV comes out. It doesn't play back very well on a monitor, but we're relatively sure we got it. And we, by the way, still have that beautiful satellite inside. It's traveling just below it.
Roger, we copy, Bill and Joe, and got a lot of happy people down here. You guys did good work.
Okay, Mike, we delivered. We got SBS off on time, and if you're interested, I'll read you the pad.
Roger, go ahead.
Deliver the crew of Shuttle Mission 5 did. Only 8 hours into the first operational flight of the Space Shuttle program. 5th flight of the orbiter Columbia. The first 4 missions were test flights to prove the space transportation system could provide access to low Earth orbit on a routine basis. Those missions laid the groundwork for the operational era. Shuttle Flight 5 was the beginning of that era. The primary purpose of the mission, to carry 2 communication satellites into orbit, deploy them from the payload bay, then return to Earth.
Columbia, Houston, 30 seconds till LOS, and everything is still go down here for deploy.
Roger, Brian, we copy that. Thank you very much. We're looking forward to having a good one.
Roger, and good luck.
Okay, Houston, this is Columbia. We are 2 for 2. We deliver. Hey, Roy, are we down now? That was, are we on the ground?
Absolutely.
A flawless landing. Only minutes after sunrise at Edwards Air Force Base, California, ended Columbia's 5th mission. Looking slightly weathered, the orbiter had traveled over 10.5 million miles in 5 flights, spent 24 days on orbit, and circled the Earth almost 400 times. It would now return to Kennedy Space Center, Florida for refurbishment, to be launched again on Shuttle Flight 9. The newest orbiter in NASA's fleet, Challenger, would fly on Shuttle Flight 6. Many weight-saving improvements had been made. The orbiter itself was almost 2,500 pounds lighter because of structural changes. The external tank weighed 10,000 pounds less than the one used on Shuttle Flight 1. The solid rocket boosters were almost 4,000 pounds lighter. The three main engines were upgraded to 104% of rated thrust. A blanket-like thermal material replaced 600 thermal tiles in non-critical areas. And all 30,000 tiles were densified to improve their durability. This stack could carry over 17,000 pounds more into orbit than Columbia.
Minus 15, 14, 13, 12, 11, 10. We'll go for main engine ignition. 7, 6. We have main engine ignition. And liftoff. Liftoff of the Orbiter Challenger and the 6th flight of the Space Shuttle. The shuttle has cleared the tower.
Challenger's underway. We got a roll program.
Houston copies, Challenger. Some late news for you, Story. We got a go for deploy. We have a go for deploy.
On Shuttle Flight 6, Challenger's cargo, the tracking and data relay satellite, TDRS, and its solid propellant inertial upper stage rocket, the IUS, weighed almost 19 tons. TDRS was the largest, most advanced communication satellite launched to date.
That is correct.
A major accomplishment in space communications. TDRS is launched from the payload bay by ejection springs, released when explosive bolts are fired. After shuttle moves a safe distance away, the first stage of the IUS rocket fires to boost the satellite from 150 miles to 22,300 miles in altitude. Then the first stage separates. Shortly thereafter, the second stage of the IUS rocket fires to circularize the satellite's orbit. Solar panels and antennas are deployed to provide power and tracking and data relay capability. Having attained a circularized altitude of 22,300 miles and traveling at the same speed as the Earth's rotation, the satellite will remain fixed in orbit over the same location continuously. Later, the first TDRS will be joined by two more identical satellites. The three will form a space communications network, providing almost continuous coverage to Earth-orbiting spacecraft, not the 15% ground stations provide. The network will be able to track 26 Earth-orbiting spacecraft simultaneously. And because TDRS satellites only relay data, they do not process it, 20 times more information will be handled by this network than could be by ground stations. All data will be relayed directly to the primary NASA ground terminal, White Sands, New Mexico, and from there via domestic satellite to other NASA centers.
Hello there, we're with you over...
Launch of TDRS was on time and nominal. First stage firing of the inertial upper stage also went well.
And Sunnyvale and White Sands send you a special attaboy.
However, halfway through the second stage firing, ground controllers lost communication with the satellite. It was an hour before even intermittent signals were picked up. They indicated TDRS had not yet separated from the IUS, and that both were tumbling at a very high rate of speed. Receiving only intermittent signals from TDRS, using short-life batteries which would soon be depleted, and getting no response to signals sent from the ground, made the outlook for Tidris bleak. Several more hours passed, and then something remarkable happened. Experts still aren't sure why, but either an automatic timing mechanism was engaged, or onboard systems finally acknowledged repeated commands from the ground, separating Tidris from the IUS.
Well, I do have some words.
Now on its own, the satellite stopped tumbling. Ground controllers commanded deployment of the solar array and antennas. However, they quickly learned Tidris was way off course and drifting farther every day. Their only hope of getting it back on course was to use the tiny hydrazine thrusters originally designed for minor attitude and velocity adjustments, not for boosting the 2.5-ton Tidris over 8,500 miles farther into space. But at least the satellite was not lost. NASA officials immediately put their plan into effect. Meanwhile, Shuttle Flight 6 continued as planned.
Okay, we're back with you in Mila for about 12 more minutes. Got a good TV picture again.
Roger, Houston. Got the hatch closed, and we're waiting for a go for depress on time.
That sounds great, Bo.
Copy, we have a go for depress on time.
That's affirmative, you have a go. And Challenger, Houston's with you over Guam for about 7.5 minutes.
Roger, hatch is open. EV1 is halfway out. They're configuring the airlock, getting ready for Dawn to come out.
Okay, we're watching.
Houston, we have a suggested setting for the DAC camera now in the sunlight. Okay, Dawn.
This was America's first spacewalk in 9 years. The astronauts were attached by safety tethers to slide wires running just inside the payload bay. They wore a new design in spacesuits, also called extravehicular mobility units. A portable life support system was worn on the back, eliminating the need for a lifeline connected to the orbiter. These suits are not custom built for each astronaut. Tops and bottoms of different sizes can be mixed. They are also more flexible than previous spacesuits. The crew removed tools from a storage locker in the front part of the payload bay.
Hooked on the door here, Connie. You want me just to leave it there? That's the inner hatch. I think it's a fine place to leave it. All right, I shall.
Then moved aft again. Using a cable run through a winch mounted on the bulkhead, then tied to the cradle that had held the IUS, the astronauts demonstrated they could have lowered the cradle manually had commands from on board failed.
There is Velcro here over the outer hatch. That's what I'm going to do, Story. Velcro in the inner hatch over there. I'm afraid I'll kick it loose.
Winch operations were tested on the front bulkhead using an Exergenie as a load to see how many pounds the winch and line could handle.
The back pocket. Okay, I'll try that.
Lastly, the tools were re-stowed, and the astronauts re-entered the spacecraft.
Indian Ocean for 2.5.
Perhaps the most visually spectacular mission since America's first landing on the moon, Shuttle Flight 7 gave us our first glimpse of the orbiter from a distance.
Another space first.
John, we have had one more of those intermittent dropouts, but the spas came right back up and no other problems.
Thank you.
The magnificent views were provided by a European payload called SPAS.
We switched over to a view looking at spas.
We copy?
Roger that.
SPAS is an acronym for Shuttle Pallet Satellite, a unique reusable space platform built by the West German aerospace company Messerschmitt Balkov Blom, with generous financial assistance from the West German Federal Ministry of Research and Technology.
Best wishes to those folks from
who built this spacecraft. It's a real...
In addition to having American television and film cameras mounted on spas, 10 experiments belonging to the West German government, the European Space Agency, and NASA were on the platform. MBB wanted to validate the satellite's design and prove experiments could be operated while SPAS was free flying. NASA wanted to show the remote manipulator system could handle the 2.5-ton payload.
And TJ, we just turned on the mass spec to warm it up. I assume that you wanted us to do that.
Affirmative, Sally. Thank you.
Okay, TJ, we're with you, and John performed a beautiful release.
Wonderful, wonderful.
The orbiter's ability to station keep with SPAS was also demonstrated. At this point, they are 1,000 feet apart. Here, SPAS and Challenger are 200 feet apart. Thrusters on board the orbiter were fired to record the effect on SPAS.
I could not get the SPAS right now.
SPAS was rebirthed for return to Earth.
They sure are nice. I've been told that some crews in the past have announced that we deliver. Well, from Flight 7, we pick up and deliver.
We certainly hope so.
The remark by Shuttle Flight 7's commander meant not only had the SPAS operation been successful, but that the crew also deployed 2 communication satellites. A Canadian satellite to be used for one of the world's first direct-to-home pay TV services, and an Indonesian satellite. It would increase high-speed data transmission and telecommunications service to that country's remote island locations.
Roger, the weather at KSC is getting worse instead of getting better, so it looks like we're a no-go for KSC.
Shuttle Flight 7 was to be the first landing of an orbiter at Kennedy Space Center, Florida. But bad weather conditions did not allow it. Challenger would touch down instead at Edwards Air Force Base, California, the alternate landing site.
We understand.
Roger.
During the period of communications blackout, usually lasting about 15 minutes, temperatures on the vehicle's surface reach their peak. The temperature of the red-hot glow seen through Challenger's front windows was about 2,400 degrees Fahrenheit. One astronaut described the view as like being inside a furnace.
Processing Western Test Range data.
Houston, Challenger, loud and clear. Nice and smooth all the way down.
Real good, Crip.
Been running about 5 to 7 tenths aileron trim on the right.
Roger, we see that.
I'll say once more, we're way to come to California.
Roger that. Challenger, Houston, rolling off the hack. Your energy looks good. Surface wind 180 at 10.
Challenger is will stop.
Roger, we see that. Congratulations, a great looking landing.
Roger that.
Approximately 2 months after TDRS was first launched from Shuttle's cargo bay on Flight 6, the final firing needed to place the satellite in its correct orbit was executed.
Copy. Go ahead for the burns.
Personnel began immediately to check out communication systems on board and initiate a series of important ground tests with the satellite essential to its operation on upcoming shuttle flights.
Processing TDRS.
First use of TDRS with shuttle was on Mission 8.
Challenger Houston with you on TDRS.
Houston, Challenger, loud and clear. How do you read a CDR?
Roger, loud and clear also.
Challenger, this is Houston with you through Hawaii for 7
Also
minutes.
conducted on Shuttle Flight 8 was checkout of the remote manipulator system and payload flight test article.
You're loud and clear too, Dale, and looks like you're right on schedule.
The 8,500-pound structure was the heaviest object lifted by the arm to date, more than double the weight of any previous payload. Data gathered during the checkout was used to plan the Solar Max repair mission. On that flight, a 20,000-pound payload would be deployed, and an orbiting satellite would be retrieved.
At 0008.
Roger, Houston, we're ready to deploy.
That's good news.
Flight 8 marked the 6th successful launch of a satellite by shuttle.
40 up here.
It was an Indian communications satellite which would bring telecommunications, television, and badly needed weather information to remote areas of that country. Because Challenger was launched at night on Shuttle Flight 8, parts of the southern hemisphere never seen or photographed from space were visible during daylight hours. The first night landing for the Space Shuttle program occurred on Mission 8 with safe touchdown of Challenger at Edwards Air Force Base, California. After making its first voyage into space on Shuttle Flight 4, the Continuous Flow Electrophoresis System, CEPHAS, flew again on Shuttle Flights 6, 7, and 8. The device is a prototype of a production unit to purify material for the treatment of disease. It was built by McDonnell Douglas Corporation and flown on shuttle as part of a joint agreement between NASA, McDonnell Douglas Corporation, and Ortho Pharmaceuticals Corporation, a subsidiary of Johnson & Johnson.
Challenger Houston.
Combined results from Flights 6 and 7 demonstrated that CEPHAS could separate over 700 times more material, and in purities 4 times higher than could be achieved in Earth's gravity. Shuttle Flight 8 was the first use of CEPHAS to separate living cells. Some of the samples were separated to continue research at Pennsylvania State University and Johnson Space Center, Texas. The McDonnell Douglas samples were used to further diabetes research at Washington University Medical School, Missouri. Other scientific activity conducted on Shuttle Flights 5 through 8 also focused, as the CEPHAS had, on research and materials processing, greatly enhanced when performed in the weightlessness of space. The monodisperse latex reactor flown on Shuttle Flights 3 and 4 flew again on missions 6 and 7 in a continuing attempt to improve the production of polystyrene latex microspheres for cancer research and treatment and glaucoma research. 5 student experiments flew on the 4 shuttle flights as part of an annual science competition co-sponsored by NASA and the National Science Teachers Association. Studies ranged from fluid convection to sponge and crystal growth to biofeedback. A total of 23 getaway special canisters were flown on Shuttle Flights 5, 6, 7, and 8. Some contained stamped envelopes from the U.S. Post Office commemorating spaceflight. Others grew snow, exposed seeds to zero gravity, and studied the effects of weightlessness on a colony of ants. NASA's Getaway Special program is a unique opportunity to fly small, self-contained payloads on board shuttle on a space-available basis at a very low cost. Perhaps the studies with the most human interest were those done on space adaptation syndrome, also known as space motion sickness, a malady which affects approximately half of all astronauts. The most extensive studies of SAS were done on Flight 8, focusing primarily on the neurological system. Oral sensitivity was tested, eye movements, and repeated physical motion. Measurements were taken of limb volume and external tissue pressure. If any of these tests looked torturous, it's no wonder the crew dubbed the doctor's mid-deck working area a chamber of horrors, and mockingly gave him a taste of his own medicine. Astronaut crews got along exceedingly well with each other on missions 5, 6, 7, and 8. Yet they were the largest, most diverse crews in the history of spaceflight. Flight 5 carried the first 4-person crew. Flight 6, calling themselves the Over-the-Hill Gang, tallied up all their years of experience to get this grand total. Flight 7 carried the first 5-person crew, including the first American woman to fly in space, Sally Ride. Flight 8 included the first black American to fly in space, Guyanne Bluford. And the oldest person to fly in space to date, Dr. William Thornton. With ejection seats gone from the flight deck, and water storage tanks and instrumentation gone from the mid-deck, there was much more room to accommodate the larger crews. There was also opportunity for privacy, exercise, and as usual on any important trip, plenty of food. The success of Flights 5, 6, 7, and 8 represented many accomplishments for the Space Shuttle program. More importantly, the missions proved the operational capability of the space transportation system, that useful work can be done in space for the benefit of people on Earth. But the program has really just begun. Third orbiter in the shuttle fleet, Discovery, will be launched in 1984. The fourth orbiter, Atlantis, will be ready for use in 1985. New astronauts are being recruited. 73 shuttle flights are scheduled through 1988. The outlook for the future of America's Space Shuttle program is excellent, and there appears to be no end in sight.